Assalamu alaikum wa rahmatullahi wa barakatuh. Dear brothers and sisters, in our last episode, we explored the astrolabe, that brilliant brass circle which brought the sky into the palm of human hands. But now we turn our gaze higher still, to the monumental structures that sought to measure the universe itself, the great observatories of the Islamic Golden Age. Long before telescopes or satellites, Muslim astronomers built vast instruments of stone and brass, transforming mountaintops and palace gardens into windows to the stars. Here, faith met mathematics, and the cosmos became a field of divine study. It began in Baghdad under the patronage of the Abbasid caliphs. At the House of Wisdom, Caliph al-Mamun, a lover of knowledge, ordered the creation of humanity's first true observatories. Two great centers emerged in the 9th century, one on Mount Qassiyun near Damascus and another at Shamasiya just outside Baghdad. Here, astronomers like Yahya ibn Abi Mansur and al-Farghani measured the obliquity of the ecliptic, the tilt of Earth's axis, with astonishing precision. They observed solar and lunar eclipses, tracked planetary motion, and verified the size of the Earth itself. For them, every measurement was an act of awe, a way to read the cosmic signs mentioned in the Quran. Indeed, in the creation of the heavens and the earth and the alternation of night and day are signs for those of understanding. Surah Al-Imran 3:190. Among these early pioneers stood al-Battani, 858 to 929, known in the West as al-Battanius. He dedicated his life to perfecting astronomical observation, not by theory, but by relentless measurement, using armillary spheres and sighting instruments of his own design. He recalculated the solar year to 365 days, 5 hours, 46 minutes, only 2 minutes off modern values. He refined the positions of hundreds of stars, corrected errors of Ptolemy, and introduced trigonometric methods that would become standard for centuries. His Zij al-Sabi, or astronomical tables, spread from Baghdad to Spain, guiding scholars, navigators, and even calendar makers for generations. Al-Battani's quest for precision reflected a larger truth, that the universe was not chaos, but perfect order, a harmony placed by Allah. By the 10th and 11th centuries, Cairo had risen as a new beacon of science. Under the Fatimid caliphs, astronomers established observatories near Al-Azhar, combining geometry, philosophy, and faith in one vision of the cosmos. Here, Ibn Yunus observed the skies for decades, compiling over 10,000 detailed entries of planetary motion. His Hakimi tables would become among the most accurate of their time, a foundation later used by European astronomers for calendar reform. With giant mural quadrants, sundials, and gnomons taller than men, they mapped the heavens without glass lenses, only with patience, intellect, and prayer. Then came the masterpiece of Islamic astronomy, the Maragha Observatory, built in 1259 by Nasir al-Tusi in Persia. It was more than a building. It was a university of the sky, with its vast circular walls, libraries, and mechanical instruments. Maragha gathered the greatest minds of the age. Al-Tusi introduced the Tusi couple, a geometric model that explained planetary motion more accurately than Ptolemy, and centuries later inspired Copernicus himself. From this mountaintop, astronomers like Qutb al-Din al-Shirazi and al-Urdi compiled new star catalogs, improved lunar theories, and refined solar parameters. The precision of their instruments rivaled anything the world had seen before, and at its heart lay a belief that studying the heavens was a form of understanding the divine harmony within creation. The observatories of Baghdad, Cairo, and Maragha produced more than data, they produced maps of the universe. Centuries earlier, Al-Sufi's book of fixed stars had already laid the foundation, but now his catalogs grew in depth and detail, recording magnitudes, colors, and even the nebulae faintly visible to the naked eye. Many of the star names we use today, Altair, Aldebaran, Vega, Rigel, Betelgeuse, come directly from Arabic, carried through these works into Latin and beyond. Each name, each coordinate was a whisper of the scholars who saw the sky not as an abstract void, but as a living testament to divine order. When the Mongols sacked Baghdad in 1258, much of the Golden Age dimmed, but its light did not die. Manuscripts from Maragha and Damascus traveled westward, reaching Spain and Sicily. In Toledo, Latin translators like Gerard of Cremona rendered Arabic star tables into works that would shape the European Renaissance. Without al-Tusi's models, without al-Battani's accuracy, and without al-Sufi's catalogs, the breakthroughs of Copernicus and Kepler would have lacked their celestial foundation. Thus, the observatories of Islam became the silent architects of modern astronomy. For Muslim astronomers, the study of the stars was never detached from belief. Every calculation of distance and declination was also a reflection on divine precision. Their work demonstrated that faith and reason were not rivals but companions, guiding humanity toward truth through different lights of the same lamp. It is He who made the sun a shining light and the moon a derived light, and determined for it phases that you may know the number of years and account of time. Surah Yunus 10:5. The observatories of the Golden Age were not only laboratories of science, they were temples of understanding where worship took the form of observation. Brothers and sisters, from the astrolabe to the observatory, the scholars of Islam transformed curiosity into devotion and calculation into contemplation. They looked to the heavens and found both science and faith written among the stars. In our next episode, we'll journey into the legacy of Ibn al-Haytham, the pioneer of optics, the man who turned light itself into a field of discovery. Jazakumullahu khairan for watching. Don't forget to like, share, and subscribe as we continue our journey through the golden age of Islam, where faith illuminated the world.